The lighter side of astronomy. This is just a light-hearted look at a few aspects of astronomy which have simply made me chuckle. So it's only a short talk, but hopefully you'll find it amusing, at least in places. So this is looking at the lighter side of astronomers and telescopes and observatories, and given that I'm keeping this short, that will probably be it, so there won't be any additional miscellanea at the end. So, as we know, some astronomers are scientists. And if you think of this question, do you think you have what it takes to be a scientist? Well, Sir Patrick would of course tell us.
Well, we just don't know.
And you can see on the right-hand side, that's pretty much what's going through my head all the time. And some astronomers are astrophysicists. And you can see some astrophysics on the board there. I'm assuming that you're all familiar with this stuff. I'll start from where we indicate on the board there and then take it up from there. Astrophysicists seem to have a knack of taking a wonderful hobby like astronomy and turning it into absolute gobbledygook. But astronomers, of course, are quite keen on classifying things. So, for instance, they will classify stars. Perhaps you're familiar with the Hertzsprung-Russell or HR diagram, in which stars are classified by putting them in a position on this graph where the vertical scale is their luminosity, usually on a logarithmic scale, and the horizontal scale is a scale of temperature, so if you like, a colour scale. Colder on the right, hotter on the left, the surface temperature running from right to left. And by plotting the stars on these particular axes, we learn something about the evolution of stars and the difference between main sequence stars and giants and dwarfs, etc. But if astronomers and astrophysicists are so keen on classifying stars according to the HR diagram, somebody once thought, well, what would happen if instead of classifying stars, what if we classified astronomers? So let's make an HR diagram of astronomers. And here astronomers are plotted on a vertical scale, which is their luminosity, or if you like, their fame. How is fame measured? Well, to give us a number, let's take the number of hits you get if you put their name into Google. So Google hits on the vertical scale, again logarithmic, and the horizontal scale, again running from right to left to mirror the original HR diagram of stars. Now we have scientific papers. So it's their scientific output that runs horizontally and how famous they are that runs vertically. And then we can plot various people on this diagram. This diagram is a few years old, so maybe some people would have moved around a little bit, but let's just have a look at a few people. I'll ask you to think about, I won't ask for a show of hands, but I'll ask you to think about, who do you think that star in the top left is that I've now highlighted? The person effectively at the top of this particular diagram, in other words, the sort of maximum fame, if you like, and way over to the left-hand side, indicating that they are very scientifically prolific in terms of the number of papers that they've published, something of order 300 or 400 papers. I'll give you just a second or two to think who that is, the most famous, most scientifically prolific individual. That is Carl Sagan. Right next door to Carl Sagan, marginally above on the fame, but somewhat lower on the number of scientific papers published, that's Stephen Hawking. If we come across, we find another individual whom I'm sure you all know, that's Brian Cox. Almost as famous, but clearly a long way down, some 20 or so scientific papers compared to a couple of hundred or so. For some reason I don't understand, way over on the right-hand side we have another individual who is apparently quite famous, but has produced no scientific output. Why this individual is there, I don't know, but that is Mylene Klass. I guess she's there because she fronted some television programs on astronomy. Other names you might recognise, Neil deGrasse Tyson, for instance, Chris Lintott, and Jocelyn Bell Burnett. So it's interesting to see these individuals and where they rank, as it were, if you plot them on a fame and scientific output basis. But when I looked at this diagram, I thought this is interesting, because the horizontal scale is scientific papers. It doesn't say scientific papers in astronomical journals. I'm a scientist. I haven't published much on the way of astronomy, but I've published a load of other things. So I have published maybe 100 or so, 110 scientific papers. Where would I fit on that diagram? So I ended up doing what most people do sooner or later, put my name into Google and see how many hits come back. Googling Steve Barrett is no good because there are lots of Steve Barretts in the world. Googling Dr. Steve Barrett doesn't help either because there are lots of Dr. Steve Barretts around the world. There's even a few in the UK. So I googled Dr. Steve Barrett, Liverpool, to try and limit it only to hits that are genuinely me, not someone else of the same name. And Google came back with about 5,000 hits. So that told me where I am in this diagram, about 5,000 on the Google hits and about 110 or so on the papers. That puts me there, right in the middle of the main sequence. Fantastic. Confirming what I've known all along, I'm a really mediocre scientist. But it's nice to know where I stand relative to these giants in the astronomical world. At least I'm not down there at the bottom, these ones labelled dark astronomers. In other words, people quite scientifically productive, but no one's ever heard of them. Okay, let's have a look at where astronomy started in the very early days. In this particular cartoon, we have a caveman looking through a hollow log, and he's rather disappointed because he's saying, "Moon still looks the same." You say this is the most powerful one you have? In this case, there's lots of hollow logs, and he's looking through various hollow logs, and of course the moon's magnification is the same in all of them, despite his disappointment. I like this cartoon for a couple of reasons, partly the main joke, but also in the background we notice there's a hollow log. It looks like it's $6, rather expensive for cavemen days, but okay. There's a hollow log for $6, and strapped to the side of it is a smaller hollow log, presumably a finder log of some kind to help you find the moon, even though they of course have exactly the same magnification. But what makes me laugh more than anything else in this is not that, and not the main joke, it's the fact that the caveman on the left is obviously trying to buy a telescope, and it's fairly obvious that the caveman on the right is the salesman. You can tell that A, from the coiffured hairstyle, but also you can tell it's the salesman because this caveman is wearing a tie. Fantastic. And of course other ancient astronomical devices such as sundials have been around for who knows how many millennia. Here we see an individual noticing that there's a partial eclipse starting, and then in the middle pane there we have a total eclipse, and of course everything goes dark, and then the sun returns. At which point he has to call out the sundial repairman. Why? Well, because he explains that as soon as the sun returned, it happened right after the eclipse, it just keeps blinking 12 o'clock. I'm sure we've all seen that. Not necessarily in a sundial, but we've seen it in other devices. Other astronomical clocks include, for instance, great stone circles. Are they clocks? Are they calendars? Probably a mixture of the two. And here, one of the architects is talking to the other and reminding him that when summertime ends, they have to give everything a slight turn to the left. Yeah, great idea. And of course there's a great deal of controversy as to how those great big stones ended up in the positions they did. And here we see one individual asking that precise question to one of his colleagues. And if we ask the question, how did the ancients manage to move these massive stones? Again, we can call on Sir Patrick.
Well, we just don't know.
But the hint in this case is actually on the left-hand side of these stones, where if we look carefully, we can see exactly how they moved these big stones. What about a few individuals? We haven't got time to cover many, so let's just pick a couple of astronomers. If we pick Galileo, for instance, we know about his exploits and his use of the telescope in the early 1600s. But being a physicist, I'm particularly interested in Galileo's experiments where he dropped objects, probably cannonballs, off the Leaning Tower of Pisa and timed how long they took to hit the ground. Do two objects of different mass take different times to hit the ground? It was difficult to get the timings right because it's only, of course, a few seconds between dropping them and having them land on the ground. And it's sometimes been asked, well, if Galileo had access to computers, would that have made a difference? Would he have been able to time falling objects more accurately if he had access to modern computers? Some say yes. Some say, well, actually, if he had access to modern computers, what he would probably have ended up doing is dropping the computers off the Leaning Tower of Pisa and seeing which one hit the ground first. So maybe it wouldn't have made any difference at all. What about Newton? Everybody has heard the story about Newton, whether it's apocryphal or not. The story goes that when he was sitting in the orchard outside Woolsthorpe Manor in Lincolnshire, he was sitting there and an apple fell on his head. Everybody has heard that story. What is not so widely appreciated is that that same afternoon, very shortly after discovering gravity, Newton discovered comedy. And for those of you with a certain sense of humour, you can take that one stage further and say later that evening, Newton discovered surrealism. I just find the idea of a grand piano falling out of a tree absolutely wonderful. What about our friend Carl Sagan, who we mentioned back in the earlier slide in the context of the Hertzsprung-Russell diagram, up there in the extreme top left of the diagram? Well, a cartoon from Gary Larson shows him as a kid, where he's looking up saying, just look at all those stars, there must be hundreds of them. And if you don't understand that joke, then you haven't heard Carl Sagan's narration of Cosmos back in the, when was it, the 1980s. And I'm sure you can figure out the humour there. Let's have a look at a few telescopes. This particular carving, I think this was from the Victorian era, looking at the gentleman in the suit, but it's difficult to work out whether this telescope ever was manufactured or whether this is just somebody's fancy. It's quite an interesting idea because if you look at the mechanics, you realise that depending on the latitude and depending on the right ascension and the declination, where is the telescope eyepiece? Well, you realise that it's always in the same place. So in this particular case, this gentleman standing perhaps on a couple of steps there to make sure his eye is at the right position for the eyepiece, if the telescope swung to different parts of the sky, that person would not have to change their height position. Quite a clever idea. And of course, amateurs over the years have been very good at building telescopes. Some amateurs have put their heart and soul into building wonderful instruments like this one on the left-hand side. I'm not so sure about the idea of making a reflecting telescope out of very shiny pieces of metal. In this case, I believe that this is made out of perhaps stainless steel, perhaps even bits of titanium in here. And so a very expensive way of making a reflecting telescope, but it does at least reflect, if you'll excuse the pun, the skill and dedication of the amateur that made this particular instrument. Some people making telescopes, well, they've really got no idea at all, but of course there are lots of skilled individuals. If we think of the smallest telescopes that have been made, one of the smallest fork-mounted telescopes I can think of, perhaps you've got a fork-mounted telescope, you know what I mean by a fork mounting. Well, one of the smallest fork-mounted telescopes I could find is actually this one. It's a small telescope which is mounted onto a fork, which is then glued onto a knife and spoon. So you can see that the knife, fork and spoon actually make a very nice tripod, and the telescope itself is sitting on the fork. A very nice idea of a small fork-mounted telescope. But if you want to know what is probably the best telescope in the world, well, you can probably guess from the way that is phrased, the best telescope in the world probably is one made out of a Carlsberg beer can. In this particular case, the top of the can was removed, a small mirror was placed in the base, much like Newton's first reflecting telescope, and then an eyepiece with a small 45-degree mirror on it was punched through the side of the beer can. And as far as I know, it was a perfectly functional telescope. It may have been rather difficult to collimate, it may not have been optically the best in the world, but still, you can decide for yourself. And of course, for some people, one telescope is simply not enough. Why have one telescope when you can have two and turn basically a pair of Dobsonian telescopes into a very large pair of binoculars? So here the light from the two telescopes is brought into a binocular eyepiece such that you can enjoy beautiful, almost three-dimensional views of the sky. And that's been taken to extremes. I'm not sure what the mirror size here is, but it looks like it could be of order 16 or so inches, maybe 20 inches. And so in this case, you of course have eyepieces that are a long way off the ground, and so you would have to use this telescope rather carefully in terms of the height you would have to be to use it effectively, especially when you're looking at objects fairly high in the sky. And for some people, even two is not enough. So for instance, if you want a large telescope, some people, rather than saying, let's go to a large aperture telescope, some people have taken a slightly different approach and say, rather than one large aperture, why not use a large number of smaller apertures? For instance, if you take a telephoto lens, this particular lens is a Canon, I think it's a 400mm f2.8, you can take a whole set of those and make yourself a relatively large aperture telescope by combining a lot of these together. Why would you do that rather than buy yourself one large telescope? Well, it has a number of advantages, and one is that you can buy one camera and one lens, and then when money becomes available you can buy another one, and then when money becomes available you can buy another one. You don't have to find all of the money up front, as it were. And in this particular case, if you put a different camera on the back of each of these 10 lenses, you can point at an object. You could, if you wish, point to different parts of the sky, or you can point all of your cameras at the same object, and there's no reason why you have to use the same filter for each of them. For one camera, you could have an H-alpha filter. For another camera, you could have an oxygen filter. For another camera, you could have red and green and blue filters. For another camera, you could leave it just with luminosity and a blank filter. The choice you have is to take all of this data simultaneously rather than the usual sequentially. And if you think that's a good idea, yes, you have to have a very sturdy mount on which to mount 10 lenses and 10 cameras. But if you wanted to do that for 10, well, why stop at 10? You could go to 24 if you so wished. I believe that is not the limit. I believe the limit so far is the idea of taking this to the limit of 48, I believe is the maximum that have been put together in one observatory. And yes, size does matter, of course. If you want to collect as much light, you either have a large number of small lenses or you build yourself the largest telescope that you can conceivably build. Dobsonians are very popular for this sort of idea. I'm not so sure that if I went to a dark sky site I would be too keen on climbing a ladder like that. A step ladder that high, if you can't see what you're doing, strikes me as a little bit on the dangerous side, and it does look like this could be a very dark sky site, given that there doesn't seem to be any population within miles from this particular location. And if we think about the largest refractor ever made, we tend to think about, well, that must be the 40-inch at Yerkes Observatory, surely. But actually the largest refractor was actually this one, with something like a 48-inch lens. It was made for the Paris exhibition in 1900, and the telescope itself was laid out in this building on these pedestals. Here we can see the business end of the telescope with the objective lens here, and you can see that the telescope itself didn't move. There's a siderostat here, a mirror that allows light from different parts of the sky to reflect into the telescope so that you can look at the sun or the moon, or in principle the stars, without the telescope itself moving. And this top section through the building indicates that the siderostat could be used to send light down the very long telescope, and then it looks like here we have an eyepiece which is then projecting an image, perhaps of the moon here, onto this big screen. So I would guess that this could be used for projecting images of the sun or projecting images of the moon to this large auditorium of people. And I'm sure that when you get an image this large, similar to an IMAX experience of today, I'm sure that would have been absolutely awesome to the people of the time of the 1900s. If we have a look at a slightly different view of it, there's a photograph where we're looking to the siderostat at the far end, and at this near end, rather than having an eyepiece, we seem to have a photographic film plate. It looks like about 2 feet or so square. It would have been huge plates that were used for this particular telescope, and there that could be replaced with an eyepiece holder. I couldn't actually find a picture of the eyepiece itself, but the size of the eyepiece holder gives you an idea of just how big that eyepiece would have been. And that, as I say, was a few inches larger than the 40-inch refractor at Yerkes. So I guess the Yerkes refractor holds the record for the largest refractor in continuous use, because this particular exhibition telescope was made for the Great Exhibition, but then as soon as the exhibition was over, I believe it was essentially dismantled. The lens went into a museum, and the rest of it, I believe, was just sold for scrap, which is a bit of a shame. Not everybody, of course, works in metal. Some people work in wood, and if you do enjoy a challenge, why not make a full-scale version of the Hubble Space Telescope out of plywood? Who wouldn't think that's a good idea? Okay, you need a fairly large garage, or in this case what looks like a warehouse, in order to make a full-scale replica of the Hubble. Other people have got somewhat smaller ideas and make Dobsonian telescopes. It looks a little more like a cannon, but this is a rather nicely made Dobsonian. Other people will buy an optical tube assembly in the conventional sense, but might choose to make an equatorial mount out of wood for themselves, for the joy of making part of the telescope. One of the ultimate amateur astronomers for telescope making was Russell Porter, and this is one of his most beautiful telescopes. You can regard it as a telescope or as a garden ornament. There's a small mirror down in the base here, a 45-degree mirror, so this is a Newtonian telescope, and a small eyepiece. And so, whether it be garden ornament or functional telescope, I can't believe that you would see a great deal through that, but it shows again the skill of telescope makers. Anybody who makes a telescope, or anybody who buys an expensive telescope, will start to say to themselves, where do I want to put this? Do I want to take it from my house or my garage outdoors each time I want to use it? Or am I going to make myself or buy myself an observatory? So there's Palomar Mountain, where we have the observatory of the 5-metre or the 200-inch telescope, which was the largest telescope in the world for basically most of my life. I visited there in 1982, that's me there. I might even be wearing the same shirt, I'm not too sure, maybe not. But in 1982 I visited the Hale telescope there, and I thought, that's an amazing telescope, and that's an even more amazing dome. That is a fantastic observatory. When I grow up, I'm going to buy myself a house with a garden big enough to put that in the bottom of the garden. Okay, I had to downsize my ideas somewhat, and a few years later, in 1998, I bought a house in which I could put a garden shed converted into an observatory. Basically a B&Q shed, an 8x6, with a hole in the floor for the telescope pier to go through, and a hinged roof that hinges back to allow me to see the sky. And if we look in from above, when the roof has been hinged back, we can see a Meade telescope sitting in there. That must have been taken very soon after I put all that together, simply because it is so clean. So that must have been the day after I put it together, because it's a lot dirtier and a lot more spiders in there now. You can also tell that this was taken a long time ago, some 20 or so years, not necessarily from the telescope, but from the laptop computer, which looks more like a house brick than it does these thin pieces of paper that you get these days. And of course, there are again examples of craftsmanship for those people who decide not to simply buy themselves a B&Q shed and convert it, but those that decide, I am going to build myself an observatory. What a wonderful structure that is, a geodesic dome as well as the octagonal structure below. It's difficult to tell exactly how big that observatory is unless you're good at judging the sizes of these flowers in the foreground, but still, regardless of its actual size, that is obviously a beautiful piece of work. And most people are happy to have telescopes in their back garden for the convenience. But of course not everybody lives in a dark sky site, and sometimes, although it's convenient to work from your back garden, you might suffer from light pollution, and it would be far better if you could take your telescope to a more remote dark sky site. Wouldn't it be nice if you could simply take your observatory with you, which unfortunately you can't do? Well, actually, yes, you can. If you buy yourself one of these, here's a wonderful example of a caravan/observatory. And if you've got a car big enough to carry this around or tow this around, you can take it to a nice dark sky site. You can do your observing in the observatory, and when you're done, you just go next door and flop in the bed. What a wonderful way of doing astronomy on the move. Some of you might like that idea but think, well, that's a bit big, my car couldn't possibly tow anything that large. Is it possible to get an observatory that you can tow that's a little bit smaller than that? Well, yes, they do come in slightly smaller models where you can tow an observatory to where you want to use it. So you could regard that as astronomy on the move, but of course you don't necessarily need to have an observatory if you want to do astronomy on the go. There are other ways of doing it. There are various telescopes which have wheels. I'm not sure if you need a license to drive this one or exactly where you sit, but there are telescopes which you can just trundle around, move to where you want to use them, park up, and then do your astronomy. So if you like, an early GoTo telescope. By no means the first GoTo telescope, because I found an even earlier one than this, and I thought this was a wonderful way of doing astronomy as well. This looks like something like maybe an 8-inch refracting telescope on top of the car. You may look at this and think, well, that's a bit impractical, isn't it? Because you can't tilt the telescope very high. You can't see objects at high altitude because of the nature of the car. But there is a crank on the side, which means if you wanted to, you can crank up that central pillar, and then you can indeed point your telescope at various objects across the sky. You do wonder about the stability of the suspension of the car, but it looks like it's possible. I wondered whether or not this was simply a publicity shot of some kind. I couldn't find any information about how it was used, and I wasn't sure about the date that this goes back to. But looking at this, I thought, well, it's obviously pretty ridiculous, isn't it? I mean, nobody in their right minds would possibly put a telescope of that size on top of a car. Unless you're an American, in which case it makes perfect sense, and you put a telescope like this, in this case on top of a Volvo. I noticed that the back end of the Volvo has got a little block of wood under it to try and stop the Volvo rocking while the individual is looking through the telescope. This individual, I believe, lived in Florida at the time this picture was taken, and perhaps he wanted to move around to different parts of Florida to visit dark sky sites to do his observing. Is that the ultimate in mobile telescopes? Well, it's pretty close. But you could argue the ultimate in mobile telescopes is actually having yourself a 747 with an infrared telescope in the back there. You can see part of it in the back there. The shutter is open and the telescope is pointing, ready to do some astronomy. This is, as you can see from the logo, this is NASA's SOFIA, the Stratospheric Observatory for Infrared Astronomy. But I think we're getting a little bit beyond amateur telescopes when we look at something that cost probably $100 million or so. And I think I've had my half hour, so I think it's about time I wrapped up and acknowledged the fact that I've taken various cartoons from various places which you can go and visit if you want to see more of this astro-related humour. Thank you all very much for listening.